Matt Singer, yum!
Hello, and welcome to another Matt Singer video. It's a beautiful day today, so we thought we'd bring Matt Singer outdoors to talk about subtraction. Specifically, we'd like to talk about why it is we're generally taught to subtract from right to left, whenever it would be more natural to subtract in the manner in which we read, from left to right. This video is a companion video to the left to right addition video that we made last time. We hope you enjoy it. Let's begin with a simple problem. 8,576 minus 2,315. Now, this particular problem poses no problems with subtracting from left to right. We can just do so column-wise. Subtracting 2 from 8, well, that gives us 6. 5 minus 3 is 2. 7 minus 1 is 6. And 6 minus 5 is, of course, 1. For a final answer of 6,261. A more challenging problem would be to subtract 2,598 from 6,214. Let's see what would happen if we chose to do this in exactly the manner in which we did the previous problem. Well, 6 minus 2 is 4. That's no problem at all. But 2 minus 5, well, if we subtract 5 from 2, what we get is negative 3, which we will put exactly in that column. 1 minus 9, well, that's negative 8. And 4 minus 8 is negative 4. And so, if we read the answer back in exactly the way we read the answer back in the previous problem, our final answer is going to be 4,000, negative 300, negative 80, negative 4. Again, that's 4,000, negative 300, negative 80, negative 4. That sounds unusual, doesn't it? But actually, there's nothing wrong with that answer. It's just that it's not the way society usually likes us to read it. Let's show you that that really is actually the answer that we should get whenever we subtract 2,598 from 6,214. Well, what we have here is a 6,000, a 200, a 10, and a 4, which make up the 6,214. Actually, if you think about it, whenever we read this number, what we're actually doing is verbally adding together its components. 6,214 is, in fact, 6,000 plus 200 plus, well, 10 and 4 is 14. Whenever we subtract the 2,598, what we get is, well, let's see. If we take the 2,000 away from the 6,000, we get 4,000. If we take the 500 away from the 200, we get negative 300. 90 from 10 is negative 80. And 8 from 4 is negative 4. Sure enough, that's 4,000, negative 300, negative 80, negative 4. Exactly the answer that we have up here. If I carried this out the way society would want us to write it, we'd actually be writing, let's see, 4,000 minus 300, that's 3,700. And then we'll subtract the 80 and we'll subtract the 4. So actually we're subtracting 84 from the 3,700. And if I do that, let's see, 3,700 minus 84, that is 3,616, I believe. You can check that out, which would be the manner in which society would expect us to express this final answer. Is this, in fact, the answer that we would get if we use the traditional right-to-left algorithm that we are generally taught in grade school to subtract two numbers? Well, let's go through the process. Starting over on the right, 4 minus 8. Well, we can't do 4 minus 8, can we? Because we wanted a positive number in the ones column as an answer. And so what are we taught to do? We're generally taught to borrow a 1 from the tens column. So generally we're taught to cross this out, put a 0 there, decrease by 1, and change the 4 to a 14. When we do that, and we continue the subtraction, we say 14 minus 8, well, that's 6. So far, so good. Going to the tens column, 0 minus 9, well, again, that's going to be a negative number. So again, we're taught to go to the next column, cross out the 2, decrease it by 1, and then borrow that 1 into the tens column. Incidentally, I always thought borrowing was a misnomer whenever we're subtracting. We actually never give that 1 back, but that's for another day. 10 minus 9 is 1. Again, so far so good. Go to the hundreds column. Now we have 1 minus 5. Can't do 1 minus 5. That would give us a negative number. We cross out the 6 in the thousands column, decrease by 1, bring that 1 borrowed into the hundreds column. 11 minus 5 is 6. And then in the thousands column, we have 5 minus 2 is 3. Sure enough, we get exactly the answer that we had gotten before. Let's revisit this problem in the manner that we did it the first time, from left to right. Well, when we took 2 from 6, we got 4. 2 minus 5 was negative 3. 1 minus 9 is negative 8. And 4 minus 8 is negative 4. And we read our answer as 4,000, negative 300, negative 80, negative 4. Again, it's completely correct, but we'd like to re-express it in the manner in which society would expect us to read it. Well, one way we could do that is, well, let's see, we don't want a negative 3 in any of our columns. In particular, this negative 3 right here represents negative 300 in the problem. What we can do is we could take 1,000 away from our final answer. In other words, take 1,000 away from 4,000. I'm going to put a little dash there to indicate that we're going to take 1 away from the 4, effectively taking 1,000 away from the answer. But then I have to reintroduce that 1,000 into the answer. Well, I'll reintroduce it in this column by recognizing that 1,000 minus the 300 is in fact 700. So I'm going to put a 7 here instead. Right? Again, that represents the 1,000 that we took away from the 4,000. Right? The 1,000 minus the 300 for a total of 700. Going to do that also here in the tens column. This negative 8 in the tens column represents a negative 80. Well, if I take the negative 80 and add 100 to it, what I'm going to get is 20. Well, I can take 100 from here. I'm going to put a little dash there to represent that I'm going to turn that 7 into a 6. effectively taking the 700, turning it into 600. But then I'm going to add that 100 back to the negative 80 for a total of 20. For the negative 4, well, negative 4, I can turn into a positive number by adding 10 to it. So I'll take 10 from 20. I'm going to put a little dash there to indicate that I'm taking 10 away from the 20, 1 away from the 2, and reintroducing that 10 into the ones column. Well, 10 minus 4 is 6. And so if I fix this up by taking the negative ones away from each of the numbers where I have a dash, my 4 becomes a 3, my 7 becomes a 6, my 2 becomes a 1, and there is no dash here, so we'll leave that as a 6. And sure enough, we wind up with exactly the answer we got in the first place. We're finally ready to introduce the left-to-right algorithm for subtraction that we've been promising. We'll do this by example. Starting from the left, 6 minus 2 is 4. No problem. 2 minus 5. Well, 2 is less than 5. So what we're going to do is 5 minus 2 instead. That gives us 3. 5 minus 2 is 3. But instead of writing a 3 in this column, we're going to write a 7. Why 7? Well, 7 is the number that you have to add to 3 to give 10. I call 7 the complement of 3. So again, 2 is less than 5, so we're going to do 5 minus 2 instead. The answer is 3. I'm going to write down the complement of 3, and I'm going to put a dash under the 4 in order to remind us that we use the complement instead. Continuing, 1 is less than 9, so we're going to do 9 minus 1. That's 8. But the complement of 8 is 2. We'll write down 2, put a dash under the 7 in the hundreds column. Proceed to the ones column now. Again, 4 is less than 8, so we're going to do 8 minus 4. That gives us 4. But the complement of 4 is 6. And we'll put a dash under the 2 to remind us that we use the complement. Finishing it up, 4 minus 1 is 3, 7 minus 1 is 6, 2 minus 1 is 1, and then the 6 stands alone at, again, 3,616. Why does this work? Well, 6 minus 2 is 4, no problem. If we did the 2 minus 5 directly, we would have had a negative 3, which actually indicates negative 300. But we don't want a negative number in that column. So what we did before was we subtracted 1,000 and then added 1,000 back in. Subtracted from the 4,000, added to the negative 300. Well, 4,000 minus 1,000 is the 3,000. Adding it back to the negative 300, 1,000 plus a negative 300, right? 1,000 minus 300 is 700. Similarly, 1 minus 9, that was negative 8. But we didn't want a negative number in that column, so we subtracted and added 100. Subtract 100 from the 700 for 600. Add 100 to the negative 80 to give us 20. And then finally, 4 minus 8, well, that would have been negative 4. So we would have subtracted 10 from the 20, added it to the negative 4, so subtract 10, add 10. Whenever we add it to the negative 4, we get a 6, and that's what gives us our result. For practice, let's apply this algorithm one more time to the problem 481,362 minus 377,429. Well, beginning over on the left, we have 4 minus 3. That's 1. 8 minus 7 is also 1. 1 minus 7, well, 1 is less than 7, and so we're going to do 7 minus 1 instead. And 7 minus 1, of course, is 6. But because we had to go to the number being subtracted to get the larger digit, instead of writing 6, we're going to write the complement of 6. The complement of 6 is 4. Write a 4 there, and we're going to indicate that we use the complement by putting a dash under the column to the left. Continuing, again, 3 is less than 4, so we're going to do 4 minus 3, get 1. The complement of 1 is 9. Write 9, put a little dash in the column to the left. Continuing, 6 minus 2 is 4. 2 is less than 9, so 9 minus 2 is 7. Complement of 7 is 3. Little dash immediately to the left. For a total of 1, 0, 3, 9, 3, 3 as a final answer. Pretty cool. Many people are surprised to learn the fact that the number 0.99999 and so on is actually equal to the number 1. As it turns out, we could use our left to right algorithm for subtraction to show that. What we're going to do is simply subtract 0.9999999 and so on from 1 and see what we get. Well, using the algorithm that we just looked at, 1 minus 0, well, that's 1 decimal point. And then, let's see, in every other place, we're going to have a 9 minus a 0. But the 9 is coming from the number being subtracted. So we're going to write in 9 minus 0 is what we're going to look at, but we're going to write down the complement of the answer. 9 minus 0 is 9. Complement of 9 is 1. But we're going to indicate that we took the complement by putting a little dash in the column next to it. Again, 9 minus 0 is 9. Complement of 9 is 1. Little dash. And so on. We're going to have a whole string of ones and dashes forever hereafter. And whenever we finish up the problem, what we're going to have is 1 minus 1 is 0. 1 minus 1 is 0. 1 minus 1 is 0, and so on. So we're going to wind up with a string of zeros, which is, in fact, 0. Well, if I subtract two numbers and I get 0, the two numbers that I subtracted must have been equal to each other. So there is a demonstration using left to right subtraction that 0.99999 indefinitely is in fact the number 1. We hope you enjoyed this Math Singer video, and we look forward to seeing you next time. So long.